All right, we're back again. This time we're talking about prisms and cylinders as well. So we're going to be looking at surface area and volume and how we can easily work through these shapes. So the first thing we have here is asking us to draw a net on the graph that when folded will create this solid. So we can see here our solid that we've got shown is a prism. It's a rectangular prism because it has a rectangular base. And its dimensions, we can see here, it's 3 wide. It is 4 deep and 2 tall. So 3 by 4 by 2 is what we would call the dimensions. So what we're going to do is we're basically going to create a net, a unfolded version of this solid. So let's see here. If I started, I could have this shape being, let's see here, 3 by 4. So if I do this, I could go 1, 2, 3, 4, 1, 2, 3. So there's my 3 by 4. And then I would have next to it, so that would cover this part of the shape. And then next to it, I could have my middle part, which would be here. This would be our 3 by 2. Oops, there we go. And then I would have the bottom, which would also be a 3 by 4. 1, 2, 3, 4. And then again, the 3 by 2 that would wrap around the other side. And then we can see here on the wings, I guess you could call it, we would need to have these two pieces on the outside that would be 4 by 2. And so I could have them coming off of the side here. There's a 4 by 2. I could have the other one opposite it there. Or I could have it moved down here and have it on this side. As long as it's part of the 4 by 2 or the 4 unit tall section, we could work it that way. We could also think of this in a different way. We could say that this is still using the same dimensions, the same size boxes, but we could create a prism instead that is 4 wide and 3 tall. So it could look a little bit different. And then we could have our, let's see here, so that would be our 4 wide and our 3 tall going this way. And then we could have our 4 by 2 coming off of that, and then our 4 by 3, and then our 4 by 2. And then again, we would have these wings, the 2 by 3. So this way, so this one was wrapping around the middle kind of from left to right, and then the front and back, the 3 by 2. Well, I could do, here's 3 wide and 2, or we could go 2 and 3. So you could go like this as well. So it even looks like they're not equal, but in fact, their areas when they wrap around would end up matching. So lots of different ways. Is there more than one net possible is our first question here? Absolutely. Yes, it just depends on how you see the dimensions. And then it asks to find the surface area and volume of the solid. So since we know that it's 3 by 4 by 2, our surface area, well, we could look at our nets and you could just count all of the squares. So here we have this 3 by 4, so this has an area of 12. We have this section here that's 4 by 2, so that has an area of 8. Here's another 12, here's another 8, and then we have the two wings that are both 6. So we could add all of that together. That would be one way to get our surface area. We could look over here just to kind of prove the point. If we were to look at the areas of each of these individual squares, oops, I can't count. That'd be 8. And that'd be 8. Are we still coming up with the same numbers, the same surface area? Yes. If we were to add all of these together, we've got 12 and 8 gives us 20. Another 12 and 8 gives us another 20, so there's 40. Plus our 6 and 6 would be 12. That gives us 52 units squared. The way we could do it using our formula, we could do, we said our formula last time. The surface area is equal to the perimeter of the base times the height of the solid plus the two base areas. So if we were to look at the numbers in here, our perimeter, if we went around 3 plus 4, there would be another 3 in the back and another 4 on the side. So we'd have 3 plus 4 is 7, and another 3 plus 4, another 7. So we would have 14 times the height of the solid, which is 2 units, plus 2 times the area of each base. Well, the area would be 3 by 4 if we're using the bottom as the base. 3 by 4 is 12. So is 28 plus 24 the same thing as 52? And sure enough, it is. So there's just a bunch of different ways to get us the same information. Our volume would be how many bricks it takes. We can see we have a base brick of block of 12 blocks in the first layer and then another 12 blocks in the second layer. So our formula for our volume is basically our base area times the height. So we know there's 12 blocks on the bottom and 2 blocks tall for that. And so that gives us our volume of 24 units cubed, cubic units for volume, because we're talking 3 dimensions now, length, width, and height, as opposed to surface area, which is just saying the length and width of multiple rectangles. So that's why surface area is still just squared. Volume now is cubed because we're thinking in the 3rd dimension.